Integration by using partial fractions. For solution of integrals of the type integration fx by gx dx, where fx and gx are algebraic functions, we use partial fractions method. Now this can be of two types as it is shown in the following table. Click on the buttons improper rational function and proper rational function to know more. Improper rational function. Divide fx by gx and get the quotient qx and the remainder rx. It can be written as fx equals to gx into qx plus rx. Therefore, integration of fx by gx dx equals integration of qx plus rx by gx dx, which is equal to integration of qx dx plus integration of rx by gx dx. Now this is case 2. Thus, we can integrate by partial fractions only when degree of numerator is less than that of denominator. Proper rational functions. Let's see the different possible conditions of problem solving. Number 1. Denominator contains no repeated linear factors, which is px plus q divided by x minus a into x minus b, where a is not equal to b. We write it as px plus q divided by x minus a into x minus b equals to a divided by x minus a plus b divided by x minus b. Now calculating a and b, the integral can be found out easily. Number 2. Denominator contains repeated linear factors, that is px plus q divided by x minus a into x minus b whole square, which is equal to a divided by x minus a plus b divided by x minus b plus c divided by x minus b whole square. Number 3. Denominator contains non-repeated quadratic factor, that is px square plus qx plus r divided by x minus a into x square plus bx plus c. It is equal to a divided by x minus a plus bx plus c divided by x square plus bx plus c. Number 4. Denominator contains repeated quadratic factor, that is px square plus qx plus r divided by x minus a into x square plus bx plus c whole square. It can be written as a divided by x minus a plus bx plus c divided by x square plus bx plus c plus dx plus e divided by x square plus bx plus c whole square. Number 5. There are some integral of the form integration fx by gx dx, which can be solved without using the above stated methods in much easier form. Let's take an example. I equals integration dx divided by x into x square plus 1. Solution. Note that it is of the type px square plus qx plus r divided by x minus a into x square plus bx plus c, which should be written as a by x minus a plus bx plus c divided by x square plus bx plus c. Instead, we can do it in the following way. Taking x square common, we get integration dx divided by x cube into 1 plus x to the power minus 2, which is equal to x to the power minus 3 dx divided by 1 plus x to the power minus 2. Now putting 1 plus x to the power minus 2 as y and differentiating it, we get minus 3 x to the power minus 3 dx equals dy. Now after substitution, we get I equals minus 1 by 3 integration dy divided by y, which after integration equals minus 1 by 3 log of y plus c. Now replacing y with 1 plus x to the power minus 2, we get the answer as minus 1 by 3 log of mod of 1 plus x to the power minus 2 plus c. Let's take an example. I equals integration 3 sin phi minus 2 into cos phi d phi divided by 5 minus cos square phi minus 4 sin phi. Solution: I equals 3 sin phi minus 2 into cos phi d phi divided by 4 plus sin square phi minus 4 sin phi. This was obtained by using the relation cos square phi equals 1 minus sin square phi. Now in this equation, putting sin phi equals to t and differentiating it, we get cos phi d phi equals dt. Now after substitution, I equals integration 3t minus 2 divided by t square minus 4t plus 4 dt. You will note that it is of the type px plus q divided by x minus a into x minus b whole square, which should be written as a by x minus a plus b by x minus b plus c divided by x minus b whole square. Therefore, using partial fractions, 3t minus 2 divided by 2 minus t whole square is written as a divided by t minus 2 plus b divided by t minus 2 whole square. Now writing it as 3t minus 2 equals a into t minus 2 plus b. After comparing the coefficients, we get a equals to 3 and b minus 2a equals to minus 2. So b comes out to be equal to 4. Now replacing the values of a and b in the equation, we get I equals integration 3 dt divided by t minus 2 plus integration 4 dt divided by t minus 2 whole square. On integrating it, we get 3 log mod t minus 2 plus minus 4 divided by t minus 2 plus c. Replacing the value of t, we get 3 log mod sin phi minus 2 minus 4 divided by sin phi minus 2 plus c. Let's take an example. I equals integration dx divided by e to the power x minus 1. Solution: putting e to the power x minus 1 equals t and differentiating it, we get e to the power x dx equals dt. Therefore, dx equals dt divided by t plus 1. Now after substitution, we get I equals to integration dt divided by t into t plus 1. From the denominator, taking t common, we get dt by t square into 1 plus 1 by t, which again can be written as integration t to the power minus 2 dt divided by 1 plus t to the power minus 1. Now again, making the substitution, 1 plus t to the power minus 1 equals to y, and differentiating it, we get minus t to the power minus 2 dt equals dy. Therefore, I becomes minus integration dy by y. On integrating, we get minus log mod 1 plus t to the power minus 1 plus c. Now replacing the value of t, we get minus log mod of 1 plus e to the power x minus 1 raised to the power minus 1 plus c.